This is a video on all the matrix transformations that you will need for AQA Level 2 GCSE Further Maths. Okay, so one of the first things you need to understand if you want to learn all the matrix transformations is the identity matrix. And before we have a look at what the identity matrix actually is, we need to have a look at what identity actually means in mathematical terms. And so this is the identity matrix that you need to know. And before we have a look at it in terms of matrices, I'm going to show you it in terms of multiplication and addition. So consider these expressions. So you've got equations, sorry. So 6 times by 1 equals 6. 127 times by 1 is 127. And this big number times by 1 is just the same number. And so what this tells us is the identity of multiplication is 1. Okay, and what that means is it's such that any number times that number is that same number itself. Okay, and let's have a look at addition now. So 6 adds 0 is 6. 127 adds 0 is the same number. Big number plus 0 is just the same big number. So the identity of addition is just 0. So any number plus 0 is just that number itself. And it's likewise for subtraction with 0 and then division with 1. So in matrices, take this identity matrix. It's going to be the same every single time for a 2 by 2 matrix. It's 1, 0, 0, 1. And the way that you read it is you go from the top left to top right, to bottom left to bottom right. So take any matrix. I picked 4, 9, 1, 4, multiplied by the identity matrix, and you get that same matrix again. So it doesn't change. So you can imagine it as any number times by 1 gives you any number. Likewise for this one. 2, 14, 3, 7, multiplied by the identity is just the same matrix itself. And then this, multiplied by the identity, is just that same one. So you can write it more generally as ABCD multiplied by 1, 0, 0, 1, which is the identity, equals ABCD. So there are 8 matrix transformations that you need to know, and these are all of them. So this is enlargement scale factor k, rotation 90 degrees clockwise about the origin, rotation 90 degrees anti-clockwise about the origin, a rotation 180 degrees, reflection in the x-axis, reflection in the y-axis, reflection in y equals x, and reflection in y equals minus x. And you don't need to memorize all of these. As long as you memorize the identity matrix, which is 1, 0, 0, 1, you can work out what all of these are. And I'm going to show you how to do that now. So, take the identity matrix. When you get into your exam, if you get a question asked about matrices, then just always write down these points that I'm going to show you. So, take this. You can imagine this as like 2 points or 2 coordinates. So where this is the x coordinate and this is the y coordinate, and this is another x coordinate and this is another y coordinate, like this. That tells us we have one point here at 1, 0, and another point at 0, 1, like this. And we can plot these on, or you can also imagine it as like 2 vectors. So this is 1, 0 as one vector, and then 0, 1 as another one. And what this is telling us is to go 1 right, so here, and then we're not moving up or down. And the second one is telling us to go, don't move left or right, but go 1 up, so it'd be here. And these correspond to the same points as the coordinates up here, so you can just plot these. So that's 1, 0, or 1, 0 like this, and this is 0, 1, or 0, 1 like this. And just to make it absolutely clear, this is where they come from. Okay, so the matrix transformations apply the transformation onto the identity matrix. And what that means is, say you want to reflect in the x-axis, you want to go from the identity matrix to whatever that matrix is, which represents a reflection in the x-axis. Now that might not make sense right now, but that's fine because I'll show you what it means in just a second. So let's have a look at a question. So always draw the same grid out, always plot on the same points for the identity matrix. So 1, 0, 0, 1. So here, here. And now we're asked, what matrix transformation represents a reflection in the x-axis? So we don't know what that matrix is. I mean, I don't even know it right now, so I'm going to work it out with you. So a reflection in the x-axis, like we said last time, we're going from the identity to whatever that matrix is. So we want to reflect in the x-axis. So let's draw on the x-axis simply. And you always start with this point here, with this first column, 1, 0. And so where does this move if you reflect it in the x-axis? Well, it just stays in the same place. So it'd be here. So it would be 1, 0. So it'd stay at 1, 0. And now this one, if you reflected it on the x-axis, it'd come all the way down here. So it'd be 0, minus 1, like this. And you can write that down like this. So remember, always start with the first point. Where does that move to? Well, this moves to 1, 0. So 1, 0. And this 0, 1. Well, it moves to 0, minus 1. So 0, minus 1. And this is just to make it more clear where it comes from. So this comes from that. And this comes from that. You always want to start with this point, and I'm going to reiterate that many times just so as to get it into your head. So identity matrix, draw it on again. We're going to have a look at another question. 1, 0, 0, 1. So 1, 0, 0, 1. What matrix transformation represents a reflection in the y-axis? So let's draw on the y-axis here. Okay, remember, start with this point, 1, 0. And that moves over here to minus 1, 0. And this one, if you were to reflect it in the y-axis, it'll just stay in the same point. So it'll be 0, 1. So let's have a look. So I'm going to do this one with you a bit slower. So remember, always starting from this point, where does it move? Well, 1, 0, it moves to minus 1, 0. So let's plug in a minus 1 there. So from here to here. So let's plug in a minus 1 and then a 0. And now this point is the next one, so second column. So it goes to 0 and then a 1, like that. And that matrix represents a reflection in the y-axis. Now, identity matrix, draw it on again, same points, 1, 0, 0, 1. You always want to start with this one, like I've said. Now, what matrix transformation represents a reflection from y equals x? This one's a little bit trickier, but it's the same thing every single time. So draw on the line y equals x, like this. You should know how to draw it. And remember, always start with this point. So this point will move over here. You can imagine it moved over here. And now 1, 0 has moved to 0, 1. And this point has moved over here to, and this point originally in the black has moved to here. So basically what's happened is 1, 0 has moved to 0, 1, and 0, 1 has moved to 1, 0, like this. So 1, 0 to 0, 1. So 1, 0 from here, then it went to here. And then 0, 1 up here, it went to 1, 0. So 1, 0. Identity matrix, again, start with this point, then this point. Imagine it like coordinates, x and y, or imagine it like vectors, so 1 right, 0 down, up, or up. 0 left or right, 1 up. What matrix transformation represents a reflection in y equals minus x? So draw on y equals minus x, it's the opposite of, it's a reflection of y equals x in the y-axis, so it'll be like this. Okay, and now if you were to reflect it, remember, always start with this point. This point, well, if it were to be reflected in this line, it'd move over here. So it'd go from 1, 0, to 0, minus 1. And now this point here, where does it move? It goes from 0, 1 to minus 1, 0. Now write that down. Remember, start with where this one's moved to. So it's moved to 0, minus 1, 0, minus 1. And then this one is moved to minus 1, 0. So minus 1, 0. Draw on your identity matrix again on the graph. 1, 0, start with this point, and then 0, 1. What matrix transformation represents a rotation 90 degrees anti-clockwise about the origin? Okay, so this one's also a little bit tricky to imagine, but it's not too much extra work. So imagine this same point here, and you want to rotate it 90 degrees anti-clockwise. So anti-clockwise would be in this direction over here. So this point is going to go to here. So it's going to go from 1, 0 to 0, 1, like this. And this point, 0, 1, the one under it, is going to go over here to minus 1, 0. So basically, we've gone from 1, 0, 1, 0 to 0, 1, 0, 1, and then from 0, 1 here, that point underneath it, went to minus 1, 0, minus 1, 0. One thing to point out is that this is not a reflection in the y-axis, because if you remember back, I think it was the second one that we did. If you look, they look almost identical, but one of the key things to point out is this point has not moved over here. This point has gone up here. If it was a reflection on the y-axis, this point would have gone over here, and this point would have stayed the same, but that's not the case here. So this one goes over here, and this one goes over here. It's just to make it more explicit. Identity matrix again, 1, 0, 1, 0, 0, 1, 0, 1. Start with this point. Now we want to rotate 90 degrees clockwise about the origin. So this point, always start with this point, is going to go over here. From 1, 0 to 0, minus 1. Here. And this point, 90 degrees clockwise, will move over here. From 0, 1 to 1, 0. Like this. And that's this matrix. So remember, this point here in black, 1, 0, has gone to 0, minus 1. So 0, minus 1. Then this point, 0, 1, has gone to 1, 0, 1, 0 here. This is not a reflection in the x-axis. It looks like it's kind of like the same as last one, but just different transformation. So this point does not move over here, because if it was a reflection in the x-axis it would, but it doesn't. So this point actually goes over here, and then this point goes over here. Oh, sorry, remember this point first. So this point goes over here, and then this point goes over here. Identity matrix again. 1, 0, 1, 0, 0, 1, 0, 1. What matrix transformation represents a rotation 180 degrees about the origin? So start with this point, rotate it 90 degrees. It doesn't matter if you go, whether you go anti-clockwise or clockwise. I think I went clockwise here. Yep, so you'd go 90 degrees and then another 90 degrees. So this point would go over here. And then this point would move 90 degrees, then 90 degrees again. So like this. Oh, sorry. Yep, from 1, 0 to minus 1, 0. This point would go 90 degrees again to 0, minus 1. Okay. And so, remember, this point goes from here to here. So it goes from 1, 0 to minus 1, 0. And this point goes from 0, 1 to 0, minus 1. Now, this is not a reflection y equals minus x, even though it looks like it. Because if it was, then this point would go over here. And this point would go over here. But it doesn't. So this point goes over here, and then over here. Like this. And then this point goes over here, and then over here. Like this. Identity matrix again. Now, for enlargements, you don't actually need to draw the graph. You can, but it's much simpler just to do it without, and it saves a lot of time. And because 3 is a scalar, it's not a matrix. So you can just do 3 times by the identity, like this. And so you just multiply every number in here by 3. So 3 times by 1 is 3. 3 times by 0 is 0. 3 times by 0 is 0. 3 times by 1 is 3. So it'll be like that. And it's the same for any other number. So if it was 10, it'd be 10, 0, 0, 10. Now, this is a question I found from one of the past papers, and it's saying, use matrix multiplication to show that in the xy plane, a rotation 90 degrees anti-clockwise about the origin, followed by a reflection in the line y equals x, is equivalent to a single reflection in the x-axis. Now, if you haven't learned what I've shown you, then you're just going to have to memorize what these are. But we can work them out. Just use the identity matrix. So remember, that's the identity. 1, 0, 0, 1. Now plot it. So let's get our graph out. Remember this one first, 1, 0. So we want to go 1, 0 here. I'm not going to label on the coordinates, but you know, it's not very hard to tell. So this is 1, 0, and then 0, 1. So 0, 1 is up here. And now we want to rotate 90 degrees anti-clockwise first. So let's find out what this transformation is. So this point, remember this point first. 90 degrees anti-clockwise will go up here. Okay, so it goes from 1, 0 to 0, 1. And then this point under it goes from 0, 1 to minus 1, 0, so down here. And you can just write that down. So we've gone from 1, 0 to 0, 1. And then we've gone from 0, 1 to minus 1, 0. 0, 1, and then minus 1, 0. Now let's get rid of these. Now let's look for the transformation which represents a reflection in y equals x. So remember, keep these same identity matrix points on. Drawing y equals x. This point always goes first, remember. So this point will go over here. So we've gone from 1, 0 to 0, 1. So remember, the first column is going to be 0, 1, so it's going to be 0 up here, and then a 1 down here. And now this point below it has gone from 0, 1 to 1, 0. Here. So we've gone from 1, 0, 1, 0 to 0, 1. And then the one below this, 0, 1, has gone to 1, 0. Here. I'm just going to say that one more time so it's a bit more clear. So we've got the point 1, 0 from the identity, and we want to reflect it in y equals x. So let's imagine where that will go. It will go over here. So we've gone from the coordinate 1, 0, 1, 0, and now we've gone to the coordinate 0, 1. So from 1, 0 to 0, 1. Now the second one on the identity is 0, 1. So where's 0, 1 moved to? So let's reflect it in the y equals x. So it's gone down here. So we've gone from 0, 1 to 1, 0, 1, 0. Now, so one thing just to keep in mind is it says this rotation is followed by a reflection. And so AQA do this a lot, but what it means is, so you've got this matrix first applied onto this. And I could make a video about matrix multiplication, how to do this a bit more properly, and go into depth in why this is. But for now, just remember, so if it says A, let's call this A, followed by B, it means multiply B first to A. So this multiplied to that. To this multiplied by that, instead of that multiplied by that, even though that's the order that they show you in. If you don't know how to do matrix multiplication, then I might make a video on it. But basically it's the first row multiplied by the first column, and then the second row multiplied by the second column. So 0 times by 0, add 1 times by 1, which gives you 1. And then 0 times by minus 1. Sorry, it's first row by first column, first row by second column, second row by first column, second row by second column. So 0 times by 0, add 1 times by 1 is 1. Then 0 times by minus 1 is 0. 1 times by 0 is 0. And then 1 times by 0 is 0, plus 0 times by 1 is 0. And then 1 times by minus 1 is minus 1. Minus 1 add 0 times 0 is 0. Sorry, no. So 1 times by minus 1 is minus 1. Add minus 1 add 0 is just minus 1. So it'd be like this. And it's saying this is equivalent to a single reflection in the x-axis. Now, you could just put an equal sign and say E equals reflection in the x-axis, and you'd get all 3 points. You'd get all 3 marks, sorry. But I'm going to show you what they mean by this. So let's get out our grid again. Let's draw in the reflection. Let's draw in the x-axis here, and it's saying So 1, 0 has moved to the point 1, 0. So this point has stayed the same. So let's reflect this in the x-axis. Remember this point first. So it's gone from 1, 0 to 1, 0. So it stayed the same, it's fine. And this point 0, 1 has gone to 0, minus 1. And that corresponds to this. So 1, 0 has gone to 1, 0. And then 0, 1 has gone to 0, minus 1. Like this. So we've gone from this column to this column, from this column to this column, and that clearly is a reflection in the x-axis. So you can say that a reflection in the x-axis equals this, and this is equal to that, so therefore that's true.